This is where it gets a little bit trickier, Liz. So we need to graph a linear relation from an equation. So now we're not given a table of values. We're just given this equation, which looks very similar to our last unit. And now we have to go ahead and make our own table of values. And then we need to graph it and do exactly the same as we did in example 1. So there's just like kind of one more element added to this. So the first thing we need to do is it says we need to create a table of values for this relation. And it says for the values of x from -3 to 3. So that's really cool. Not all the time does it give us the value. Sometimes we just have to make up our own value. So what we want to do is we want to eventually make this table of values where on the left is always the x and on the right is always the y. And it says it wants us to do x values from -3. So we do it in this order. So -3, -2, -1, 0, 1, 2, 3. Okay, and our job is, so it's given us the x values and our jobs are to figure out the y values. So we actually look at this equation and we do something that we were doing in the last unit, which was called substitution. So what this is saying is if x is -3, what will y be? So we actually need to take that -3 and plug it right into the equation. So it's going to look like this. So we have y is equal to 6 minus 3, but we're going to see what does this equal when x is equal to -3, our first value. And you can totally use a calculator for this, but I'm just going to show you how it works out. So this will end up being 6, and then we got to go 3 times -3, which is -9. And it's going to end up being 6, and this is going to change your signs around because it's subtraction of integers, and you're going to have y is equal to 15. Then you're going to plug in to the equation. So you're going to come back to your equation. And this time you're going to plug in -2. So what's equal if x is -2? So it's going to be 6 minus -6, which will end up being 12. And again, those numbers can all go into your calculator. What about when x is equal to -1? Well, then we're going to get 6 minus 3 times -1. That's going to be 6 minus -3. We're going to flip our signs, and that 6 is equal to 9. And you might start to see a pattern forming here. And I'm just going to do one more. So what happens when x is equal to 0? Well, that just cancels off. We're going to have equal 6 minus 0, because 3 times 0 is 0. And we're left with 6. So you might start to see a pattern at this point. From 15, 12, 9, 6, you might see a pattern that it goes down by 3 each time. So we can kind of predict the next ones without even having to plug it into our equation, that this will be 3, 0, and then -3. So now we have our table of values. And now the next part of this question tells us to graph the relation. And then there's that question again, does it make sense to join the points in the graph? Explain. So first we need to graph our equation. And this time we have negatives and we have positives. So we actually want to be very careful how we graph it. So we're actually going to use all 4 quadrants. Remember those quadrant terms. I'm going to draw my vertical line. And I'm going to draw and it doesn't have to be super perfect, but I'm just going to show you what it looks like. You know what, we're going to probably have to actually move down. Oops, nope, that's not what I want to do. This line here is probably actually going to have to be a little bit bigger. And this line probably have to move down a bit. Okay, so then you just go ahead and you plot your points. And so the first point here that we need to plot is -3 and 15. So then we go so -3, so this would be, so we go x is first, x is always first. So it's 1, 2, 3 in the negative, and then 15 up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So right there. Okay, then the next one is going to be -2 and 12. So there. And the next one is going to be -1 and 9. And then when x is 0, so when x is right on y is equal to 0, we're actually going to cross at the y-intercept, it's called. Remember your vocab, the y-intercept at 6. And then we're going to keep going down, and our x-intercept is at 2. And then a little bit further down, we have here. And we can actually see, and you should see, there should be no reason why you don't see a straight line forming. And I'm not going to join the points yet, so we're just not ready. But you can start to see that there is definitely a straight line or a linear equation going on. So we're going to go back to, this is part B. And this was A. So it says, does this make sense to join the points in the graph? Well, it does actually make sense because we don't have like cost of hamburgers or cost of DVDs. So yes, it does make sense because you can have a fraction of a number. Like here, we're not given CD sales, DVD sales, those types of things. So here it actually doesn't matter that we join them. So you can have a fraction, because you can have a fraction of a number. So I'm just going to add a line to this. Oops. Ooh, I didn't want to do that. I'll make it a red line. Oh, and I just missed it a little bit, but that's okay because the power of technology. I can just pick it up and move it. And you can see that there, in fact, I do have a straight line. So we've answered B as we've explained it. Now C says, again, it's that same question. C, I'll change it back to black. C says, what are the patterns emerging from this table? So so on the graph, it should be exactly the same as the pattern that you see in your table, really. But on the graph, as you move from one point to the next, from one point to the next, you move one right, like one to the right, like one unit to the right, and 3 down. And this is where you get a negative slope or a negative line, whereas other ones we were dealing with are always positive. So we have x will increase by 1, but y decreases by 3. And we're always trying to build our answers, right? And then the last question here will probably be, asking, is this relation linear? Justify your response. Well, it is a linear because the points make a straight line. And this one, because there's no end point, we can actually extend this line forever and ever and ever. And when we do this, we actually put arrows on the end of our graphs to show that it will go, that this graph will go on and on and on. And that's when it goes on and on and on, that's when we call it continuous. So that might bring some bells there for your math journal. So you could always add to your math journal at this point about, here's a continuous linear relation. What does it mean? Well, you have to look at the pattern, make sure that as the x moves over, the y moves over at the same amount, that the points form a straight line. Those are all important to continuous linear relations. So here we just solved a question where we were given a formula. We made a table of values by using a little bit of some math skills, and then we formed a graph.